In this program, you're going to build a 4-note piano that uses a turn knob to set the key that the piano plays in. We're going to use a variable in this program, but we're not setting it above the void setup like we have in previous programs with variables. We'll see why when we get into the loop. In the void setup, use the pin mode function to set port A2 as an input. That's where the turn knob is plugged in on the smaller block of ports at the bottom of MakerBoard. The center pin needs to be in the A2 port, but it doesn't matter which outside port is in power and which outside port is in ground. Next, use a pin mode function with the arguments A5 and output to set up your speaker. Next, you'll use 4 pin mode functions for ports 2, 5, 8, and 11 and set them all as input pull-ups. That's where your buttons are plugged in. You'll notice I left some blank lines in the void setup. That's not required for the code to work correctly, but it helps me stay organized and separate the different groups of components that I'm using. Within the void loop of this program, the first thing we'll do is create a variable. We need to decide what type of variable it is. We're going to use an integer, which is shortened to int, and that means it's a whole number with no decimal places. The name of the variable comes next, and I've named it low note because this variable is going to stand in for the value of the lowest note our piano can play. In previous projects, we've set the value of the variable equal to a number, like 1000. Instead, we're going to use a function to determine the variable's value here. It is analog read of A2. Analog read works by going out to port A2 and checking its value. The turn knob can send a value from 0 to 1023 into your program. So, depending on how far the turn knob has turned, this value could be anything from 0 to 1023. And that's going to be our low note variable value. The reason that we have this variable created inside the void loop is that we want the variable to be updated every time the void loop runs. This is what's going to allow you to change the key of your entire piano constantly as you're using it. So every time the void loop runs, it's going to say, okay, we have a variable called low note, and I need to check analog read of A2 to determine what its value is. So this variable is getting created and checked every single time the void loop runs. The next line in our void loop is an if statement. The if statement has 2 key parts. Between its parentheses is a condition that gets checked, and between its curly braces is the actions that run if the condition is true. So, if the digital read of port 2 is low, meaning the button on port 2 is pressed, then the actions between the curly braces will run. The actions in this if statement is just a tone function. The tone function has 2 arguments, the port where the speaker's plugged in, and the hertz value that we want to play on that port. Instead of using a number for the hertz value, we're going to use low note, our variable for that hertz value. And remember, low note is coming from the analog read of A2. So we have a sensor that's setting the value of a variable, and then we have a variable that's setting the value of a tone. If digital read of 2 is not equal to low, meaning button 2 is not pressed, then the if statement actions are going to get skipped, and the code is going to check the condition in this else if statement. So it's checking to see, is button 5 pressed? If it is, then on port A5, play a value of low note times 2. So again, we're using this analog read of A2 to set the value of low note. Then we're using low note in this tone function times 2 to set the hertz value of the second key on our piano. If button 5 is not pressed, the code will check button 8 and see if that's pressed. If it is, and that else if condition is true, then a tone on port A5 will play, and the value of that tone is going to be low note times 3. If button 8 isn't pressed, then the code checks button 11, and if button 11 is pressed, it will play low note times 4 as the Hertz value on port A5. Finally, if none of the conditions in the if-else-if statements are true, the else statement will run, and that turns off any tone that's playing on the speaker. Once the code reaches the end of the void loop and sees that closing curly brace, it's going to jump back to the top of the void loop and run again. The first thing it does in the void loop is say, okay, we have a variable named low note, and I need to read analog port A2 to see what the value of that variable is. This means that you can play with your piano and twist the knob as you're doing so to change how high or low your lowest note is. And because you're changing the value of low note, you're also changing the value of low note times 2, low note times 3, and low note times 4. So this is a fun way to use the knob to determine the variable value, then use the variable value instead of a Hertz number. So you can create a piano that you can change the pitch of anytime you want.